So, this is a text problem, and I want you to do this 3 ways. Now, I'm going to do a different version of this problem, and I think you'll see what to do. And I'll point out when I'm all done doing my different version, I'll relate it back to this problem. But you'll probably see that. So I get sine x cos x. That's the version I'm going to do. And I'm going to do this in 3 different ways. Now, remember when you pick your u sub, what you're looking for is, whatever you pick for u, you want to see something close to the derivative. So I say if u is equal to sine, well, the derivative of sine is cosine. So that is pretty fortuitous, which is just an academic way of saying lucky. So du dx is equal to cos x, and our procedure calls us to solve for du. Our du is du in the problem, so I'm going to isolate du, and we get cos x dx. So this is my substitution table, and I'm going to box that off because that's really being polite to whoever's grading your work, and that's always a smart thing to do. Okay, so there's my u, and I get u cos x dx. Right there I go. That's going to be my du. So I get a nice simple integral, u du. Okay, so I integrate it, add 1 to the exponent, divide by 2, and add the constant of integration, back substitute. And I get sine squared x plus 2. So that's the first way to do it. So got that one done. Okay, so that's the first way. Here's the second way. So here's my problem. Same problem. Whoops. Sine x cos x dx, same problem. I'm going to set u is equal to cos x this time. Du dx, well, the derivative of cos is minus sine. Again, I have that here. This is going to be my u, then that looks pretty close. And so I'll get du alone. And there I go. Okay, so this integral, boom, write it over here. I'm going to get sine x u dx. Remember, our goal is to get rid of every occurrence of x in the problem, so I get all the x terms together. I need to solve for that. Well, it's pretty clear. Here, let me box this off. That sine x dx is going to be equal to minus du. I'll bring that minus outside. And I integrate. Okay, pretty much the same as this one. And I get this answer. 2 different ways so far, and each of them produces what looks like a different answer. Okay. Now we're going to look at the third way to do this problem. And I want to remind you, in order to do that, I want to remind you of a trig identity. And we have this identity, 2 sine theta cos theta is equal to the sine of 2 theta. Okay, pretty standard identity. So I look at this integral over here, sine x cos x dx, and, well, what's that equal to? I'm just going to solve for the sine theta cos theta over there. This tells me that sine theta cos theta is equal to sine of 2 theta over 2. Again, it doesn't matter what I call the theta or u, the theta or an x. The theta is just meant the angle. So I can rewrite this angle now. So here I'm thinking that my theta is just x. That's my angle. So this is now equal to not sine x cos x, but sine 2x over 2 dx. Remember, I can factor out the 1/2. Now I have to integrate. Now I have a formula for sine x but not sine 2x. So what do I do there? Well, that's going to be my u. Remember, the rule for u is you look for whatever is having something done to it. That's one of the rules for u. And here are I'm doing something to the 2x. I'm taking the sine. So then du dx is equal to 1/2. du is equal to 1/2 dx. Feel free to start skipping that whenever you feel like it. Okay, there's my subtable. So this integral now becomes 1/2 sine u dx. I need to get rid of my dx. I need to get rid of that term. Well, dx is going to be 1/2 du. So I get this 1/2. I get another 1/2 when I substitute for my dx. I'm going to bring that outside. I get 1/4 sine u du. Well, integral of sine, look at my tables, minus cos plus the constant of integration. So I'm just going to do a little cleanup work here, get rid of the minus sign. I'm going to have cos, not cos u, but 2x, and back over to there. It's going to be over 4 plus c. So there's my third answer. So here's an interesting question. I'm going to come back to how this relates to my original problem, and I'm going to discuss why I have 3 different answers and how to deal with that. So I'll take care of that in the next video.